Okay, so I want to talk about the ray diagram and sign conventions for a flat mirror. Nothing crazy here. Here's a flat mirror. You can see around the room here. Let's see some carpet blowers. Can I get those? Oh, how about a weird guitar? There's a weird guitar there. Okay, all right. So now in this case, let's just get into it. All right, so a flat mirror is actually a special case of a concave spherical mirror. But think, what's the radius of curvature? Well, the more curvy something is, the smaller the radius of curvature, right? Whereas a large radius of a large radius of curvature would be way over there. A small radius of curvature would be right here. So in this case, as you get closer and closer to flat, the radius essentially goes to infinity. Now, what was our equation for the focal length? It was radius over 2. Well, infinity over 2, still infinity. Think, what is that going to do to the this 1 over f? That's going to go to 0. So notice, what do we get here for d image? Negative d object. Notice, oh, whoops, this is wrong. Heights with no minus sign, distances with the minus sign. So notice, in this case, what is the magnification? Negative d object over, negative of negative d object, it's 1. This is why when you look in a flat mirror, you look the same size, magnification of 1. Notice height image should equal height of the object. Notice height image is not negative, right? So we expect the image should be positive. Now look, let's talk about the sign conventions. If you recall, d object distance was positive if it's on the front side. This being the front, that being the back. Okay? So notice d image is positive on the front side, but we have a negative image. That means the image should form behind the mirror. That's why when you look in the mirror, it looks like your image is behind the mirror. And then your eye can see that. You can't put a piece of film behind the mirror and actually, so this is called a virtual image. Okay, so let's try and draw the ray diagram. And here's where I have to get a little bit tricky. I'm going to introduce a fourth ray that I didn't describe in the previous video. Ray 1, that's the same one as before. In parallel, out through the focal point. But now what's crazy is the focal point is not here, it's not here, it's not here. It's way over here at infinity. So it should be going way out this way, and if it really is perfectly flat, it's going to end up coming straight back. Like this. Now, remember what I said. Back extend the reflected ray, or the output ray. So I do not want to back extend this one, because that would be going this way. I'm going to back extend this one, which is going this way. I know that seems a little silly. I'm just trying to say things the same way so when we get the lenses we don't get confused or tricky mirrors. So we always want to back extend the output ray. By that, there's no actual ray going this way, so I draw a dotted line. And next, let's try ray 4. This is a funky little ray. We're going to hit the center of the mirror. So we go from here. And we want this to use angle of incidence equals angle of reflection. The easiest way to do that is to take your object, which is 10 centimeters tall, put another dot down here directly below it, so that you get the same angle. Which ray do we back extend? The input ray or the output ray? Let me get that lid. be clear, this is ray 4. This one up here, we call it ray 1. I back extend the output ray. Where they intersect, I get an image. Now, my ray diagram isn't perfect. We expect if I have a 30 centimeter object, I should have exactly a 30, but it's hard for me to draw. You can see some wonkiness in the lines. So just to clean that up a little bit, I'm just going to put this here and kind of draw it really sloppy and cover up my mistake. But that gives you an idea of how to draw that. Hopefully you could draw a better one than me. Now, some special consequences that we saw out of this. The focal length is infinity, and so it doesn't matter whether you use plus or minus in this equation, does it? Because you'll get 0 whether you use plus or minus infinity. But the magnification we saw was 1, positive. The image is the same size, and it is upright, the same side as the optic axis. All right, and this image is virtual. That's what we say if the image distance is negative here, or if you can't put an actual piece of film here. Another way to say it is the light rays never actually touch. Only the back extensions touch. Virtual. Can't put a piece of film there because no light actually goes there. All right, that's it.